Welcome friends to the session of marketing research and analysis, where we have been discussing about structural equation modeling and which talks about the interrelationships or the multiple relationships and how one can derive inferences out of it, in which we just started with what is a structural equation model and how it is connected with factor analysis and multiple regression and chi-square, right, being some of the important tools used to understand structural equation modeling. Then we spoke about two important things, one being the measurement model and the structural model. So, the measurement model, which we start with when we talk about SEM. SEM has two important parts, you can understand that way. So, one is the measurement model, right. Here we explain the the relationship of the variables with the factor, right. So, a researcher tests, it's also called as a confirmatory factor analysis, right, confirmatory factor. So, where you are confirming, as a researcher you are confirming the relationship between the variables and the factor, right. So, this is already a priori, it is something that the researcher has already defined the relationship, right, and now he is only confirming it. So, that is why it is a confirmatory, otherwise it would have been a exploratory. So, you are not exploring anything, you are only trying to confirm, right, whether the relationship theoretically that you have found out, or some experiment or some kind of a discussion, some expert opinion, whatever. So, whatever you have found out, now is it coming true or not, right, are the variables loading onto the factor properly, nicely or not, that is what we do basically, right. And the second part, once you have done it, second part is to test the structure. The structure is like, for example, structural model. So, here this is something like a path analysis, we say, right, a visual depiction is called a path analysis. So, in a path analysis what we are doing is basically we are trying to formulate some relationships, right, A, B, let us say is affecting, let us say C, okay. So, A and B are affecting C. So, C in this case is my dependent variable and A and B together are affecting my dependent variable. So, this is a case which we will measure, right. So, this could be one thing, but this looks like a simple a multiple regression, but what if the relationship becomes little more complicated, let us make it little more complicated, right. So, it is becoming something like this. Now, C is then affecting D and now this relationship has become more than a multiple regression, right. So, you can if you try to explain it through a multiple regression you can, but then we will not get the we will not be able to understand the error terms properly in this case, right. So, let us understand what is this CFA first and then we will go across. So, confirmatory factor analysis, what is it and why we use it, let us say. So, the definition says it is similar to EFA in some respects, but philosophically very different. Why philosophically different? I had already explained that there is already theoretical backing. With CFA the researcher must specify both the factors that exist within a set of variables and which factor each variable will load highly on before results can be computed. That means the researcher tells it beforehand ki what will be the relationship without even testing it, right, because the testing can only be done later on. So, the technique does not assign variables to factors, instead the researcher must be able to make this assignment before any results can be obtained. SEM is then applied to test the extent to which a researcher's priori pattern of factor loading represents the actual data. So, in this case what is he doing is trying to say ki whether what I have thought is true or not true, right, as good as that. So, what are the features? The measurement error terms are independent of each other and of the factors, right. So, the error terms are independent of each other. Now, what are the error terms? So, we are saying, so this is a construct, so and this is let us say the error term, right, and this is another construct and this is its error term, let us say, right. So, now the error terms are independent of each other, right. and all association between the factors are unanalyzed. So, we will basically we say it is a covariance structure. So, covariance kind of a relationship, so it is a special correlation, right. So, and this is what exactly is happening, right. But there are cases to improve the model, we will look into the measurement errors also. We will see whether we can try to connect the, we will do some is there any relationship between the error terms too, and by doing that will the model significantly affect have a grow positively, we will see, right. CFA is confirmatory, the number of factors and the pattern of indicator factor loadings are specified in advance, right. So, for example, we will say that variable 1 will have a larger bearing or larger effect on the factor, right. So, we have defined already CFA analyzes the variance covariance matrix of unstandardized variables. Now, the last thing it says is it is pre-specified factor solution is evaluated in terms of how well it reproduces the sample covariance matrix of measured variables. So, now, so what is CFA basically doing is, in CFA we are trying to build a model and test this model whether as per our knowledge whether the model, whether the variables are loading properly and the construct is a valid construct or not. This is what we are basically doing here, right. It fixes cross loadings to 0, that means what? Now, let me draw it and show you what does, how it would look like, right. Generally I have seen, I have said, what I have said is, now this is a construct and this has let us say 3 variables, let us say, and this is another construct and this has got 3 variables. Now, we are saying that these variables are independently fixed to only certain factor, but what if one factor is loading into another construct, let us say one factor is loading into another construct. So, that is a cross loading, case of a cross loading. EFA models may involve cross loadings of indicators, in EFA that provision is there, but in CFA cross loadings are fixed to 0, that means they are treated as not existing, right. Okay. And errors are assumed to be uncorrelated, this is very important. Now, what did I say? In EFA model, in the beginning of my last session also I had said this, I believe, I remember that in EFA the cross load, the error terms are uncorrelated, but in CFA the errors, because a error is not an error by the word which we understand, a error is nothing but the unexplained variance, right. So, why can't there be a relationship between the unexplained variance, right. So, in case there is a relationship that would surely affect my model, right. So, where it is used to evaluation of test instruments, that means test instruments are my constructs to evaluate whether my instruments that I am using, the constructs that I am using are valid enough or not, right, the validity. Construct validation is done by convergent validity and discriminant validity. Now, convergent validity, as I said, now suppose these are the variables, right. So, these variables are my, now suppose the variables will have a higher convergent validity if the inter item correlation, that means if the correlation among the variables is sufficiently high, right, that means they are correlated with each other, right. On the other hand, discriminant validity is something that is used to measure that two different constructs are separate, are distinctly separate from each other, right. How do we do it? There are methods which I will be explaining in this. There are 2 popular methods which we use to do it. One is the basis of the variance extracted and the other is through the chi-square, right. I will explain it. So, development and testing of the measurement model for an SEM. For the first part is to see that the measurement model is proper or not, right. What are the advantages of CFA? CFA the fit of the measurement model, it helps in measuring the fit of the measurement model before estimating the structural model. That means before you get into the structural model of the relationship, right, of the among the constructs, before that you can already confirm, you can confirm that my constructs are valid, right, are justified. Relationship among variables are by adjusting for measurement errors. One more important thing is, in SEM models you can establish relationships by adjusting for the measurement error. Now this is what I said, we sometimes we use a term called modification indices, right. Through the modification indices we try to reduce the measurement error, right, by not reduce, we adjust the measurement error by creating a relationship among the variables, the error terms, right. Now look at this, this is a simple case, this is two things, there are two constructs, right, supervisor support, work environment, right. Maybe this is the researcher is trying to, this is a measurement theory, he is trying to find out a relationship between these two constructs, latent constructs, right, supervisor support and work environment. Now these four are the variables for the first case and x5 to x8 are the variables for the second case, work environment. Now these variables are already predefined, as I have already said many a times, I am repeatedly using, it has come out of theory, prior knowledge, literature, and they are predefined, okay. And these you can see E1, E2, E3, E4 are all my unexplained the error terms, right. So each variable will have a error term obviously, because there is some part which is explained, there is some part which is not explained, okay. Now what is this LX1, LX2, LX3 and LX4, LX till LX8, these are all my loadings, these are all my loadings, that means the correlation of the variable with the factor, right, that particular variable with the factor. So LX1 is a correlation between the x1 and the factor supervisor support, right. So convergent validity, it one of the biggest advantages of CFA SEM is ability to assess the construct validity. Now construct validity means the construct that you are using, that should be valid, right. If somebody has used it somewhere, it is not necessary that it will be valid in a new environment altogether, right. So construct validity is the extent to which a set of measured items actually reflect the theoretical latent construct they are designed to measure. Now please you can think about it again, you can read and think about it. What is saying? Construct validity is the extent to which a set of measured items, the variables which I said, actually reflect the theoretical hidden construct, latent is hidden construct they are designed to measure. That means they are actually measuring what they are intended to measure, right. So convergent validity is measured through the factor loadings, right, through a high factor loading is a good indicator. The variance extracted, now variance extracted means how much of variance, the mean variance extracted or the average variance extracted, we say the variance extracted in any study, in any among the variables and the construct will help us to understand how much of variance has been explained. If it is we have a cutoff value of 0.5, the AVE value, average variance extracted, is 0.5. So any value above 0.5 is good, but any value below 0.5 means that it is not explaining properly, right. And the third is the reliability, for which we use the in a case of generally in a exploratory factor analysis we were using the Cronbach's alpha. The Cronbach's alpha was a reliability value which was, we said that it has to be more than 0.7 in social science, but Harron Anderson in their book they have been very clear and they have said even in social science a 0.6, a 60% explanation is good enough, right. And there is something called a composite so composite reliability, right. So composite reliability is a score which we do measure. Now what is how it is measured? Now lambda square, which is a composite reliability, is equal to lambda square by lambda square plus 1 minus lambda square. So lambda is nothing but the factor loading value. If you know this factor loading, then you can obviously tell it from there that the square of it, and 1 minus lambda is the error, 1 minus lambda is the error, right. So, you can measure it, right. So, discriminant here also I have written discriminant validity which I said we will see, right. So, let us go into this. So, standardized loadings should be 0.5 or higher and ideally 0.7 or higher, right. So, what is it saying? That means the loadings that you see here, these loadings, the values, right, the estimates you can say in one way. So, these loadings, this is a this should not happen. So, I am deleting this part, there should not be any cross loading. So, the loading should be 0.5 or higher. If the loading is 0.5, what does it mean? That means if my correlation is 0.5, I am explaining 25%. If it is 0.7, I am explaining almost 50%, right. Average variance extracted should be 0.5, which I just said should be 0.5 or greater to suggest adequate convergent validity. If the AVE score, which is average variance extracted, right, which is also you can it is lambda square by n basically. So, if you measure this take out this AVE, it should be more than 0.5. AVE estimates for 2 factors also should be greater than the square of the correlation. Now, this is how you check the discriminant validity. This part is an evidence of the discriminant validity. Now, this is where students get confused, researchers get confused a lot. Now, what does it mean? It means that if when there are 2 constructs, right, the AVE score, as it says, the AVE estimates for 2 factors, that means factor A F1 F2, let us say F1 F2. Now, the AVE estimate should be right, suppose this is the correlation, let us say R, right. So, the AVE estimate should be greater than the square of the correlation, that means AVE should be greater than the square the square of the correlation among them, right. So, if this is happening, then the research, this is a very strong way, this is a very sufficiently strong way of, even you can write in your research papers that if you have achieved this, then the researcher has achieved a discriminant validity. There is one more way of doing a discriminant validity also through the factor model where we look in the change in the chi-square value, which we will which I will show, which I will tell you later on. So, construct validity, so construct reliability, the one should be 0.7, which the formula which I have written should be 0.7 or higher to indicate adequate convergence or internal consistency. So, if this value is greater than 0.7 or 70%, then you can assume that you are achieving a high internal consistency, right. Now, stages of CFA, as it says, you first define the individual constructs, then develop the overall measurement model. In just remember, only difference between the measurement model and a structural model is that in the measurement model you do not have any directional relationships, okay. It is a covariance model, and every factor or every construct is related to each other, right. So, only let us say 2 factors are there. So, these 2 factors are correlated. So, in this we are not taking any independent relationships, okay. So, designing a study to produce empirical results, assess the measurement model validity. So, if you can see, if as I have written here, CFA involves stage 1 to 4. Now, 1 to 4 individual construct definition, measurement model, then producing the empirical results. Now, how you get this empirical result, I will just explain that, then assess the measurement model validity, and last 2 is what you do in SCM is in the stage 5 and 6, specify the structural model and assess the validity of the structural model. So, if you do this much, entire SCM is over, right. So, let us see this first part, right. So, define constructs. So, if you go back, it said define the constructs, right. So, list constructs that will comprise the measurement model, which construct should be a part of the measurement model, and determine if existing scales are available or can be modified to test your measurement. That means what? If you have, for example, some scales which is already built by somebody, some researcher, you can use it, it is much easier. But suppose you this is sometimes this question comes to the mind of people, right. Suppose can I use my own? Yes, you can. If it has been, you have tested it and it has been tested with the backing of some theory, you can use it, no issues, right. You can even modify, you can modify a scale, but remember there is no issue in doing all these things, because ultimately you will have to check the validity of the scale, because if you make any changes, then the validity, or you do not make, you anyway you are checking the validity, right. So, if you see that there is, it is a valid instrument, then all the problems are gone, right. Third thing is, if existing scales are not available, then you can develop new scales, that is what I have been always emphasizing, okay. So, define so as it says, it should display adequate construct validity, which we discussed, right. And even previously, so this is already discussed, so I am not discussing further, right. Content validity should be of primary importance. See, this is something which we should not ever neglect, because research is a complete thing. So, if you by any chance feel something is less important than the rest, then we are sorry, this is a wrong thing. We should always go for a face validity, a content validity, by checking it through experts with their opinion and all, right. Pre-test should be used to purify measures prior to confirmation testing. Now, what does it say? Now, before you test the relationships, because if you suppose have brought something, right, some kind of a instrument, that instrument should be, before actual production starts, that instrument should be pre-tested. What happens if if you have not tested the instrument and suddenly you try using it in the main production, suddenly the machine does not work. So, what will happen? If the machine does not work, then maybe the whole process can come to a halt, or it can give you erroneous results. So, all these things to avoid, you should always pre-test the instruments, right. So, what you should see, the key issues, no cross loading should be there, right. Covariance or within constant error variances, so that means three things basically. You should understand that there is no covariance between or within the construct error variances, means the error. Do not get, please understand this. So, these are the, suppose my this is a variable and this is the error 1, this is another variable, this is the error 2, similarly this is my error 3. So, there should, do not try to establish unnecessarily a relationship between the error terms, right. If required, there are ways to do it, which I have said already, the modification indexes, which is used to do that, but at the moment just understand this. Then is, how many items am I using, items per construct. Now, suppose you have too few constructs, right, too few items, then there is a problem that can occur, is that you can say it is an under identified construct. Sometimes it is just the right one, right, and sometimes we have over identified constructs are always better. What is, how do you understand this over identified, under identified? Suppose there are let us say this is one variable, it has got one construct, two variables, let us say, and each construct has got a error term, each variable has got a error term, right. So, you are calculating two things, one the error, right, and here the loading, right. So, four things you are calculating, but suppose how many actually variables you have? Now, 2, right. So, 2, if I am having 2 variables, so 2 into n, actually the formula goes n into n plus 1 divided by 2. So, as per that we have 2 into 3 by 2, so 3, what remains is 3, right, but we need 4 things to calculate. So, that is why it is a case which we said under identified. In some cases it will become, if you have let us say 4 let us say 4 variables and you need 8 relationships. So, 4 into 5 by 2. So, 2 5 already you have 10. So, if you need to calculate 8, no issues with it, right. So, that is what you need to understand. So, this is how it looks like. Each measured variable is related to exactly one construct. So, no cross loadings, okay. This is a case of a cross loading, you see, this is a cross loading. I think this is clear, and here this is, there is another cross loading. So, this is not to be allowed, and errors are, in this case errors are not independent, which is wrong. One should not be trying to do it until and unless there is a highly there is a serious requirement, right. One should avoid any kind of a relationship between the error terms. So, developing the overall measurement model in standard CFA applications, we are testing, and the latent constant should be indicated by at least 3 measured variables, probably 4 or more is also preferable, right, and they should be statistically then identified. Now, this is something like there are 2 things, this is important: formative factors and reflective factors. Now, formative factors are slightly different to reflective factors. What do they mean? I think it has not been mentioned here, but let us say a case, sometimes I think I explained in my last session also, in sometimes it depends, the relationship between, let us say the 2 variables, right, let us say the 2 variables could be that, or let us say this is a construct and a variable, right. So, this is the construct, this is the variable. So, C could be affecting V, or it could be that C is getting affected by V. So, in this is a case which generally we talk about. So, this is a this is a case of a reflective construct, right, and this is a formative construct. So, in the reflective construct, we what we are trying is that the construct is affecting the variable, right, and in the other case we are saying that the variable is affecting the construct. Now, it is written out here, you can see formative constructs are not latent, right, and are not validated, right. Suppose in this case, oh sorry, this is, I think I said reflective, this is the formative, that means the construct, no this is reflective, sorry, this is reflective, this is formative. So, the construct is affecting the variable, which is actually a classical situation, but in this case the variable is affecting. Now, suppose as I said, suppose this is a social class. Social class is getting explained by, let us say the income, let us say religion, let us say something else, right. So, this is a case, these are 2 different cases, right. We will not get too much into this, because still what it is saying is formative constructs are not latent and not validated as are conventional reflective factors, okay. Internal consistency and reliability are not important in the case of a formative construct, right, factors. The variables make up a formative factor should explain the largest portion of variance in the formative construct itself and should relate highly to other constructs that are conceptually related. So, what it is saying is the formative constructs, although there has to be a certain degree of correlation among the constructs among each other or within themselves, right. So, and the minimum correlation value should be 0.5. What it says is formative factors represent greater difficulties with statistical identification. Obviously, most of the time what we use is reflective constructs, right, most of the studies, and we seldom use, we use less the the formative constructs, okay. Items in this is the beautiful part, that in a the difference between a reflective and a formative construct is that in a formative construct we do not drop an item just because of its poor loading, but in case of a reflective construct in CFA also what we do is when an item or a variable does not justify a sufficient loading onto the factor, then this item is an very good case for deletion, one should delete it, right. With reflective models, any item that is not expected to correlate highly with the other indicators of a factor should be deleted. What is it saying? Any item that is not expected to correlate theoretically should be automatically deleted. Okay. Now, how do you check the model fitness? Now, you have done through CFA. Now, after doing CFA, you need to check whether the model is valid or not valid, right. To check the validity of a model, I said there are certain ways of doing it. This is some tests which are highly used. The goodness of fit test, right. The goodness of fit test is a test which says that a specified model reproduces the observed covariance matrix. If you remember, I had said that there is an observed matrix and there is an expected matrix, and the difference between the observed and the expected matrix should be very, very low. Now, how is it possible? When the chi-square value, should be less, that means when the chi-square value, suppose you have two models, right, and if you are checking both the models, the difference in the models, if it is low, then it is a good situation, right. So, there is and it means that it is that is what chi-square does. Chi-square is a goodness of fit test basically, right. So, this is what it says. The second thing is the construct validity. So, the extent to which a set of measured variables actually represent the theoretically latent construct that are designed to measure. So, we have discussed about it also, right. So, the composite reliability, how to calculate and all. These are some of the tests. Before that, let me go to the values, right. So, the different values, if you do not understand, if you want to just remember it, remember this much, there are certain values called the absolute fit indices, right. During any confirmatory factor analysis, or then later on the structural equation, the structural model also, for that the measurement of the structural model, both for both the things, the same fitness indices are used. And in this case, when the fitness indices are that you are using, they need to be sufficiently large, above 0.9 or more, right. But there is a small but here. In case you have an extremely large sample size, then it is the researcher should know that even a fit indices of little less than 0.9, around 0.88 or just 9 is not bad enough, right. It is still adequate and good, right. And what is this root mean square error? This is a value which has been ideal value has been given to be 0.08. Anything below 0.08 is good enough, right. So, these are some of the indices, the values which you will find while doing a test, and if these values are if you are getting within the limits, then your model is fit, right. So, the best way to find your model fit is just find out calculate the chi-square by degree of freedom. This value, if it is anything less than 3, if this value is less than 3, right, then your model is fit, right. Although researchers say anything till 5 also is good, even sometimes they say 10, but I would always advise you to go for a chi-square by degree of freedom value of maximum up to 3, right. Anything below 3, that means your model is fitting, right. So, this is how you test the fitness of the model, and so these are some of the more the values, everything all these values have to be around 0.9, right. And then I explained the discriminant validity. I explained through that average variance extraction and the correlation, the square AVE should be greater than the squared correlation. So, when you do this, you find the discriminant validity. So, this is all you do to check, validate and explain the constructs, right. And then once you have done, your constructs are valid in nature, then the next step comes is to test the relationships through a structural model. We will take it up in the next session. This is what we will discuss. This is what we have discussed today, and thank you very much for this session.